Welcome to another of my Math BGCSE tutorial. This lesson is being presented by Peter Smith. This tutorial is not a detailed lesson. It is for revision purpose. This problem we are about to look at is the BGCSE Past Examination question, Paper 2, Question 15. This examination came on May 19, 2015. It reads, 2 wires, AB and DB, tether a balloon to the level ground, as shown in the diagram. DB equals 192 meters, DC equals 32 meters, and angle BAC equals 70 degrees. This diagram is marked not to scale. The meaning of the phrase not to scale is that the drawing does not represent the real lengths or measures. You are to calculate, giving your answer to the nearest whole number, the height of the balloon, BC. Note that BC is this distance. In this diagram we are seeing more than one triangles. This is a trigonometry problem which involves right-angled triangle. So, first we are going to identify which of the right-angled triangles we are going to involve in finding the distance BC. We can use triangle BDC. BD is the hypotenuse. DC is the length of one of the shorter sides. We have two sides and we are to find the third side. Therefore, we can apply the Pythagorean theorem. BC equals the square root of 192 squared, minus 32 squared. Squaring each of these numbers under the radical gives us BC equals the square root of 36,864 minus 1,024. Taking the difference of these numbers gives us BC equals root 35,840. Thus, BC equals 189 meters. When round to the nearest whole number. Part B requires you to calculate angle BDC. Triangle BDC is the same triangle we have just used in Part A. We must now identify where the acute angle must be located. The angle must be located at D. Now, let us label the sides of a triangle. "32 is on the side adjacent to where the angle will be at D. 192 is on the hypotenuse. Previously, we found BC to be 189 meters. This is the opposite side. Now, we can see that we have the length of the three sides. We do not need the three sides to find the size of an angle. All we need to use is two sides. So we will decide on which two sides we are going to use. I am going to use adjacent and hypotenuse. The adjacent is 32 and the hypotenuse is 192. Which trigonometric ratio contains adjacent and hypotenuse? Sa, Ka, Toa. Which of these? It is Ka, the one with the A and the H. This is the cosine formula. Cosine is adjacent divided by hypotenuse. So we have cosine of angle D equals adjacent. 32. Divided by hypotenuse. 192. After dividing these two numbers, we have cosine D equals 0.1667. I suggest that you round to at least 4 decimals places, when the number you are rounding is not your final answer. Then, D equals the inverse cosine of 0.1667. Finally, angle D equals 80 degrees. When correct to the nearest whole number. Part C requires us to find the length of a wire, AB. Remember, in all of these problems, the triangles we are working with have to be a right-angled triangle. First, we need to identify the right-angled triangle we are going to involve, in order to solve for AB. To find the length, AB, we must take the large triangle ABC. The acute angle we will be using is the 70 degrees. Now let us label the sides of this triangle. AB is the hypotenuse. 189 is on the side opposite the acute angle. AC is the adjacent side. But we do not need to involve this side. Also, we do not have any value for the adjacent. The two terms we are going to involve are opposite and hypotenuse. Which ratio contains opposite and hypotenuse? Sa, Ka, Toa. Which of these? It is Sa, the one with the O and the H. This is the sine formula. Therefore, we will use the sine formula to find the distance AB. Sine equals opposite divided by hypotenuse. Sine 70 degrees equals 189 divided by AB. Sine 70 degrees is 0.9397. So, we have 0.9397 equals 189 divided by AB. Then we cross multiply and get 0.9397 times AB equals 189. Therefore, AB equals 189 divided by 0.9397. Thus, AB equals 201 meters, when correct to the nearest whole number. This is the end of this lesson. You have just watched a lesson on trigonometry. This lesson was presented by Peter Smith. Please join me in another lesson where we learn more important math topics. Let us think of education as a tool for developing our greatest abilities, because in each of us, there is a private hope and dream.